In this DX tutorial, what we're going to do is follow along with one of the other tutorials that I did on scan alignment. I'm going to take the same data set and show how to align this data to the CAD's world coordinate system. So if I turn on the planes for the CAD world coordinate system, you see this part is floating out in space. And if I just hit the front view, you'll see that it's just floating in there. And you'll notice that it's floating in a way that the origin over here is where the scanner originally was, and when I scanned it, this is the table that it sat on in the vise, right? So a lot of scanners, the part is actually in an orientation in reference to its zero, and that's usually the way it works. And then what we're going to do is move this in a logical way over to the coordinate system there. That way, when you model it, it's actually in an area that makes sense, that you can do something with, right? You can model it this way, but good luck trying to square things up and everything. It'll be a lot of extra work to do. You can do it, but you need to go ahead and align it before you start modeling. So aligning is the first step in the modeling process before you start reverse engineering a part. So in order to do that, you don't have to create regions, but I'm going to go ahead and create regions because it also shows how to do that as well. So if I come in here and I like starting with 20 and select the mesh that I'm working with and then hit apply. While that's running, I'll just explain what the region group is. This is a triangle or polygon object, right? And those triangles are flat, three-sided objects, right? Now, the triangles have neighbors, and if they are perfectly flat, there's a 0-degree angle between those neighbors, right? But if they are not perfectly flat, which this shape is described by triangles, they have different common angles between them. So this auto segment region group, what it's going to do is group triangles by common curvature or angles between those triangles. And what it inherently does, as you can see, is makes it really easy to select regions of the part. Again, why we call it the region grouping tool or regions. It makes it really easy to just grab that whole face and use it to best fit a plane or whatever. So these are like a giant saved selection is one way that I put it too. Now, when you create it, when you do an auto segment, it's going to run with those basic settings, and it almost never is perfect, but it usually gets really close. And if I see areas that I might want to break up, I'll just come in and I'll use some of these tools up here to break up regions. So if I just select an area and I hit insert, it'll go ahead and insert a region into the part. So if I just hit grab that and then hit insert, you'll see that it'll create a new region from that. Now you see it has split and merge and all those other things. I'll use merge here on the other side. I noticed I have to toggle back over to the rectangle selector tool to like grab multiple regions, but this region and that region are really just the same CAD surface, right? So if I grab both of those and I hit merge, it'll create them as one, right? Now I don't, like with most things, I don't want to do extra work that I don't have to do. So I'm not going to go around here and group every single one of these little regions together and make them perfect. You know, if something like this is bothering me, I might just take in all that text, I'll just make it all one giant region just to break it out. I'm not going to do anything with that modeling wise anyway, and it does make it a little easier on the software if it is one group. But again, I'm not going to spend tons of time. I'll just break regions the way I think they should be broken based on what I'm going to try to do with the data here. So you see that top surface here. Here's another area. That top surface is flat all the way till it gets over here, and then it starts to break and then go down. So I will take a look at that and just define an area that I would probably like to split it. So if I just come in here and I grab that and I just hit insert, as you can see, instead of using split and using many different tools, I just find it easier to keep it simple with one or two tools to utilize here. It just makes it simple. And again, Now that I broke those up, they're separate regions, even though they're kind of one flat area. So I will grab that one, right? Because this is flat area. And then I'll merge them together. And you could do that with this face. I could remove that fillet right there and break it here so that I can use it. But I might not end up using it in what I'm about to do. We'll see. I'll align this a few different ways. That way you can see some different techniques. And then what I'm going to do here is I'm going to look, this is flat over here, right? And I went too far. So I'm going to break up, because I want to use that flat surface there. I'm going to use it for something. And break that so that way this is a flat area and then that just kind of goes off. Now once I have this, let me go ahead and save. And we'll go ahead and jump over to alignment. So in order to align this to the world coordinate system, you're going to use this interactive alignment tool. Now you can use, there are three different types of geometry that I plug into this tool to align. One simple one, as we're about to do here, is use those regions. I'm going to click on regions and then align the part to the world coordinate system with that. Another one is to create reference geometry, like fitting these planes and axes and points, and then aligning based on those. And then the third is actually just sketching. So if I draw a 3D sketch, I mean a 2D sketch or a mesh sketch on the part, I can use that sketch to align. So I will actually do all three. To start out with, let's just say that we want to align this part and make the center axis of this cylinder right on top, the center point, 0. And then we want to square that axis up to like the y-axis and then make it the part go off to our right. So in order to do that, we'll just come into interactive alignment. We'll click on the mesh. And you see you have two windows. I like to do this where I shrink that down because this is my 0. And as I input the geometry over here, this 0 will move around and these directions on the gimbal will face the directions that they're constrained to, right? So once I got inside of this dialog, there's two different main methods of aligning. One of them is 3-2-1, which 3-2-1 is kind of an industry term for a plane line point that's usually used in the inspection and metrology world. And the idea there is it's a plane, honestly. It's just that one plane and you select the second plane, those two planes make a line. And if you select a third plane, if you intersect all three of those orthogonal-ish planes, then it will create a point. So that's why they call 3-2-1 plane line point. I accidentally hit the enter key on my keyboard, so I got out of the command. So that's what 3-2-1 is. So it's a very specific, simple alignment, and it's made to align like a block very fast. Now, as you can see, this part is not a block. This is actually, most people, when they look at this part, might be afraid of how to go about aligning it, but it's actually a lot easier than it looks once you dive in. There's a lot of geometry on here that you can use to align with. So the XYZ method is actually interesting because you have your position and your directions broken out into separate dialogues here. So position is where is the 0 going to be? So how do I put 0 right there? And then the directions is how do I square up the different planes and axes with the widget, the XYZ0, the origin, right? This guy right here, if you look down here. So if I wanted to square up this cylinder with the y-axis of that coordinate system, how do I do that? So I will show you now. So in order to constrain the position, remember I said I want to put 0 right here. In order to do that, I can click on that cylinder and then that top plane. And what our software does is it will assume, because I selected a planar region and a cylindrical region, that if you have a cylinder and a plane and they intersect, put 0 at the location where they intersect. Now, remember I said I want to make I want to constrain that cylinder with the y-axis. So I can reuse that same cylinder and say I want to constrain that with y. Now, if I want this cylinder, I could use this cylinder, I could constrain it with z. I could use that plane and constrain it with the z-axis because I could square that. That's actually a good way to do it. I could just say square the z-axis with that flat plane right there. So now you see I put 0 right there. And now if I hit accept, front view, we put 0 right at that coordinate system. So it's very organic looking part, but there's a lot of geometry there to actually align with. So we aligned with regions. Sometimes regions are not the best way because the 0 is not easy to select by clicking that plane in that axis. Maybe that's not an option to be able to do, because of the geometry of a sculpture or something like that. So you can actually create construction geometry to align with as well. So when I say construction geometry, you can come in and I can say, I want to fit a vector or an axis. Some people call it an axis. And we have all these different construction methods to extract a vector from scan data. And one of them is find cylinder axis. So this is really cool. The software is able to take all of that data and calculate what a cylinder axis would be from that data. So you can construct, just like I did before, I can essentially build a 0. Now, if I want I'm going to not use the cylinder this time, but I want the plane to be down the middle. So how would I do that? This isn't a symmetrical part, but these two planes on each side are essentially symmetrical, right? So what I can do is I can come over here and I can fit a plane to that surface. Let me hide my base geometry there so you can see just what I'm fitting. So I fit a plane there, and then I can come over and fit a plane on the other side. So now I got these, in theory, parallel planes. If I select both of those planes and I go back into the plane again, there's all these different methods, but it'll automatically assume if I have two parallel planes that I want to average those together. So I can make an average plane down the middle between those two. And then I could fit a plane there. See that? So instead of using that other one, I'm going to use this one. Now, when I go back into the alignment tool, I can use these. But another thing you can do is if you, just like I did before, I can select this vector and that plane to create a 0 if I want the 0 to be there. But I could also just go ahead and create it if I want to as a point. So you can do it both ways. So now if I go into interactive alignment, select the mesh I want to align, come over here and I can click on that point as my position, or I can say this plane and vector, and it will automatically give me the same thing. Now, if I want to say my y-axis is square to that, and then you'll see that y went the other way because the plane is facing that way. But if I want to flip the vector, I can do so. And then if I want z to be squared up to that same plane that I made down the middle, I can do so. And the same thing happened there where it's flipped. So now I just put 0 right there. And now if I hit square up, you can see I squared it in a very similar way, but 0 is here instead of there. So it looks like it's in the same orientation, but it's slightly different. Unless this location and that are like collinear, then 0 is up there, I mean down here instead of up there, but they're just whatever dimension that is off from each other. Okay, so I went ahead and I did that based on features. So I'm going to undo and let it go back to its original location. Now, With sketches, what I'll often do is just like I made this plane down the middle by averaging two planes, I'll average two planes or I'll create a symmetry plane because we can calculate a mirror plane in those same construction tools. I can do that with the sketch method. I can actually come in and I can right click and say, let's do a mesh sketch and select the mesh that I want to work on, this one. And then I am going to go ahead and silhouette the part like that, and then accept. So now I can go in and square up, and I'm in a mesh sketch, and then this is my geometry here. See, the idea now is I can draw 0 wherever I want it to be. So in this instance, what I'm going to do is I'm going to best fit a circle, and then I'm just going to draw a line and a line like that. And then I can utilize other areas. So if I wanted to fit a line there, and then let's say I want to use that. So what I often will do is I'll go ahead and make these guys fixed. And you can square these. Sometimes these are easy to square to something, but I can come over here and I can say, I want to make those parallel. I want to make these parallel. And I would be a little more accurate than I am being right now, right? So the idea here is awesome because I could actually draw 0 anywhere I want to and just square these with that. And I could even infer where a 0 might be. So just giving another example here. If I want 0 to be at the intersection of these two cylinders, but these two cylinders are square. Oops, I need to make this fixed as well. Make it fixed. Let's go ahead and make that one fixed while we're at it. So I can come over here and say this is parallel. That is parallel. And let's say that's where I want my 0 to be, right? So one thing that I'll do is I like to put a circle around it and then I'll extend one side like that. That way, that's where my 0 is going to be. And then you'll see why in a second why I do that. And so the advantage of this one, as you can see, is 0 doesn't have to be anywhere on the part. I can draw 0 and square things to whatever I want them to be squared to. So I could put 0 right here or right there. Now when I get out of the command, turn on my mesh, you see that there's my 0 out in space. I can come over interactive alignment, select the mesh I want to use, come over here and say, I want this to be my 0. I'm going to orient the part. I always like orienting the part the way I actually want to align it on screen. That way I make this and this match each other, right? That's how I'm able to do it faster is I put the part the way I want it to be oriented, and then I make the widget or gimbal match what I actually expect it to be. So now if I say I want my Y axis, which Y is up in this CAD system, you can change that of course, and then X is that way. So Y up, X, Z is at me. I could do the same thing. I could put it over there. But you see the advantage of this one is I'd have to do a lot of construction entities to put this out here. I could do it with features. I definitely can. This is just easier to sketch where I want it to be. Now when I hit OK, the sketch does not move. That's one of the little caveats with this, is the sketch doesn't go with it, but it doesn't matter because the part is now in that coordinate system. And I'll go ahead and hide my sketches, and 0 is at the intersection of these two, but squared to the edge of that and the edge of that. So I could have easily used squaring it to the cylinder axis and squaring it to that top plane if I wanted to. Not a big deal. But I'm just trying to show as many different options to cover bases of alignment um, and help people out. So that is my overview of aligning using the interactive alignment tool to the world coordinate system inside of Design X.